Okay, so we're going to look at a little bit more of an advanced cipher. So this is, again, we're going to be replacing letters with different letters. So this is a classic one known as Caesar's cipher. So what you need to picture in this one is like two discs that you can spin, and then if you offset it by a certain amount, then it will tell you which letter each other one represents it. So if you move it 6 positions, A won't be equal to B. A will be equal to B, C, D, E, F, because it'll be 6 letters away. Wait, that's 5. But we're going to set this so that it will make fewer errors than I just did, because we're going to be using a computer. So with Caesar's cipher here, we're going to start with part of the ROT1 program. So if you haven't seen that yet, please go back and take a look. Otherwise, you can take a look at the code that I've already got programmed here. Maybe pause the video to copy this down. I usually don't want to copy and paste too much from other programs, because that's when I tend to make errors by copying and pasting and then reconfiguring it incorrectly. So I've got just the basic components here. So now in this one, what we're going to be doing is rearranging this part a little bit. So we need a little bit more information as we're doing this. So we need the original letter, and then we're going to do some work. So we're going to shift the letter over. So this is the, think about this as like the displacement between the original letter and then which letter it ends up becoming as part of the code. And then the code letter will tell us which one it is being replaced by. So this is kind of the replacement one. So we're going to start with the letter, and then we're going to shift it a bunch of positions down to the code letter. And that's what we're going to have. So in this one, we're going to prompt the user for the message to encode. But then we're also going to prompt the user for the degree of shifting. So prompt for degrees of shifting. So we'll do another prompt here. Enter the shift that you wish to use. Okay. Now the shift is going to be input.next int, because this will be an integer value. We're moving forward a certain amount of positions. And then now what we need to do is we need to traverse the original message and change all the letters to their shifted equivalents. Okay. So this is going to start like any traversal for loop. So we're going to start with I, while I is less than original dot length, I plus plus. And then here, we're going to have two possibilities. So if it is a letter, which I'm going to code in just a second, we're going to do something. And then otherwise, it's not a letter. So we're just simply going to have the coded solution result get whatever character it is. So original dot substring I comma I plus 1. Okay, and just for the purpose of testing this, let's print out our partially created coded message at every step. So we're going to start with identifying if it was a letter in the alphabet. So we're going to check to see if alphabet.index of, so again, to check to see if it contains the letter, original dot substring I comma I plus 1. So we're going to check to see if our letter that we're on here is not equal to -1, which will define it as being part of the alphabet. Now, the letter we have to identify from the alphabet is going to be alphabet dot index of. So which letter is it? We're going to be looking at the substring of the original text. So when we do that, we start with original, which is the string that we're pulling the letter from, dot substring I comma I plus 1. So again, we're going to be storing the number value of whatever letter we're currently looking at from original one. And we do that by finding what its position is using index of in the original alphabet. So to kind of decode these, you might want to start at the right and then work your way back to the root of the statement. So now, what do we do with the shift? So now our code letter is going to be equal to letter plus shift. So now here's the problem is, imagine that you had a shift of 10 and you had a Z, or let's go with a Z, which is 25 plus 10 is 35. Now, you don't have a letter 35, and if you try to put it in, you're going to crash your program. So again, the key to this is imagining this as like a circle or a disc. What we want to do is we want to rotate through the numbers, and we already have a mechanism for this that we have been using. So our code letter, we're going to essentially put this on a wheel by using modulus. So what we're going to do is we're going to use modulus to get the remainder of a division by 26. So remember, the highest that we can possibly get here is 25, which is, think about that, that's our letter Z. And then the lowest, like imagine that we had 52. So 52 modulus 26 is equal to 0. So this will give us a number that is from 0 to 25. So essentially the numbers just count up 0 to 25 and then start again at 0 and go to 25. And then what we'll do is we'll add on to the coded answer a letter from alphabet. So alphabet dot substring. And now what we want to do is we want to go from the code letter to the code letter plus 1. So let's try this out. Oh. So I'm just going to do a quick save before I go ahead and do this. And okay, enter the text to be encoded. Let's say I would like to order a water. And the shift we want to use, let's go a shift of 1. So when we do a shift of 1, you can see that one at a time, it pulls the next letter in the alphabet. I becomes J, W becomes X, O becomes P, and so on and so on. Now this one, however, we can do better than Rot 1. I would like to order a turkey sandwich. And if I want to make a shift of 3, all of a sudden, this becomes much harder to read. So by using modulus, we can guarantee that we're going to be pulling a letter from the alphabet from 0 to 25. And then by using shift, we can make our code a lot more difficult to figure out.